Well, it's telling me that I'm live. Hopefully, I've also done it so that everyone can hear everyone else and not just me, because that's boring.
Not boring. We're going to be famous. It's going to be great.
Let's just have a look.
I'm actually eating chocolate. If you know me eating chocolate, I'm so hungry. So
all right,
that's what I'm doing. I tried this last night. I got nowhere with it at all. So it's not going to be as quick as last week anyway, lads. So be prepared. I'm baffled. I don't understand.
I did it yesterday as well, and I was tired when I did it. I should have left it till I wasn't. And I made a complete hash of question 3 in total. So I
looked at question 3 and I was like, no, I'm not doing that.
I think I probably should have looked at my notes, but I looked at it and thought, oh yeah, I know how to do that. And it turns out, no,
that's the problem. It looks like, because the figures are you're so familiar with figures, you know what they're trying to do, but you don't know how to get there. So you think, I don't need to look at my notes, and then it just goes, make hands of it. But I don't even know, I can't, but I'm noticing with the notes, I'm just struggling to find what I'm supposed to get out of them. So we don't have Jen this week. Not Jen, we don't have, I can't think of her name. Our tutor, her name's after going out of my head.
Jane.
She gave good examples for last week's one, so we're kind of up this week. We'll try and go. I'll share my screen. We'll do our best here. Okay. So in the first question, they're asking how much air and water is on the Earth. So in this problem, we will estimate how much air is in the Earth's atmosphere and water in its oceans. The average atmospheric pressure at ground level is 1.0 by 10 to the power 5 pascals, and Earth is a sphere of radius 6,400 kilometers. Assume that the acceleration due to gravity is 9.8 meters per second squared. It's also a constant throughout the atmosphere. Hint: recall the equation for pressure. Remember that the surface area of a sphere is given by A is equal to 4 pi r squared. So question 1, estimate the total mass of air in the atmosphere.
I don't know about you, but I went off into terra incognita with this one initially. I was trying to work out all sorts of things, and then finally the universe took pity on me, and inspiration struck, and it turned out to be very, very straightforward.
I went through literally 5 formulas trying, because they said what to recall the equation for pressure. So I whipped out that equation, and I realized, oh sure, I don't have this and don't have that. So I went 5 steps back, and let me know. Tell me how straightforward this is, because it was not to me.
Right. Well, yeah. You start with the pressure equation. So pressure equals force over area.
Yeah.
But you think to yourself, well, I'm after mass here, and there's no mass in that. But there is if you replace the force with F equals ma. So you end up with P equals ma over area.
Oh.
And
okay.
So
that would make more sense.
So it is genuinely that simple. You just write in the value of P, which it gives you the atmospheric pressure, pascals, and it's just times
the mass we don't. The acceleration is, I presume, acceleration due to gravity.
Yeah. And the area, that's
area.
right. The area, you have to obviously work out the area from the A equals 4 pi r squared.
Yeah.
So first step is work out the area, and then just knock it into the equation there. He gives the radius in kilometers, so you need to change it to meters before you work out the area. And all the units all cancel out nicely as well, so you only end up with kilograms in the end, so you sort of know you've got the right answer. So yeah, that was, like I say, that was a lot easier. I mean, I was trying to work out. I don't
know what I was trying to do.
I couldn't.
I got velocity, then acceleration. Then I tried to get force, and then when I got force, I tried to get the mass, and it worked out to about 93,000 or some blah blah blah. But it just didn't. I don't know.
If you go on the interwebs, you can find all sorts of websites that will convert things like pascals to what was it? I found kilograms force per meter squared. So you end up with a conversion factor, and I sort of looked into all of that, and I did it with that conversion factor, and now I got the same number out, so I was fairly confident that I'd got the answer right, but I couldn't, in good conscience, just sort of, leave it at having gone on the internet and typed the number into a conversion website. So
I did it in one of the other few questions. You'll see when we come to it. I just found a converter because I wasn't asked to be trying to trudge through my notes. So
sorry.
We're not. Go ahead.
Can I be annoying and ask what was the power of 10 that you got? I did the exact same thing, but I never converted to meters because I think the answer was in kilometers at the end. I'm not certain.
Well, I got 10 to the power of 18.
Oh, okay, right. Okay, minus.
Yeah, it's because the area, to work out the area, you need to be changing the kilometres to metres.
Yeah, perfect, thanks.
Perfect.
So, and then the second part of the question, obviously you get the area figure that you worked out earlier, work out what 70% of that is.
Yeah.
And then you're doing exactly the same thing. You've got exactly the same equation, except this time the pressure is the 4 times 10 to the 7 times the area, the 70% of the area, again over 9.8 simples.
Okay, perfect. So same equation, except the pressure is 70% of the original pressure.
No, the area is 70%.
Oh, the area. So the area going to be minus 70% of the original area. Right, perfect. Okay, question 2. So this question involves calculating the pressure in a lake and the volume involved in a lake. Atmospheric pressure may be assumed to be 1.0 by 10 to the power 5 Pascal, and the temperature is constant throughout a lake. Take that of water to be 8,000 kilograms per meters cubed, and the acceleration due to gravity to be 9.8 meters per second. Hint, recall the equation for pressure and consider a column of water extending from the bottom of the lake to the surface at height equal to the lake depth. So how deep is the lake if the pressure at the bottom is 10 times that of normal atmospheric pressure? And I have nothing written for this at all. I didn't even try it. So, anyone have any ideas?
Again, I worked it out, but it mightn't be right.
You know what? Just throw that into the air at this stage. I don't know if it'll happen. So.
Okay. Well, do you remember that I think it was hydrostatic pressure? Pressure is equal to density times gravity times the height.
Yeah.
Yeah, so, well, we're given that the pressure at the bottom of the lake is 1 times 10 to the power of 6. So if you put that in for pressure and equate it to 1,000, which is your density, times the gravity, which is 9.8, and leave h as h, and then just rearrange, and that was it.
Oh, that is so much easier than I thought it would be.
Don't worry, I have that all the time.
Okay. I literally stated this for 30 minutes last night and then I gave up. Okay.
Yeah, that's what I did as well.
Yeah, very good.
So yeah, pressure equals h times rho times g.
Yeah.
H times rho. Gee, brilliant. Okay, question 4. The gas bubble rises from the bottom of the lake in part 8. The surface, its volume just below the surface, is 7.0 by 10 to the power minus 5 meters cubed. What is the bubble's volume at the bottom of the lake?
Yeah.
Use Boyle's law, blah, 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 blah.
Yeah, Boyle's law. P1 times V1 equals P2 times V2. Rearrange it because it's V2 that you're after.
Yeah.
And I just assumed that P1 was 1, working in atmospheres. It doesn't really matter what sort of pressure units you use, but I just assume P1 is 1 because that's at the top of the lake. That's 1 atmosphere. At the bottom of the lake it's 10 atmospheres because you're told it's 10 times. So
and the volume is just what's given there at the 7 point.
Yeah, V1 is you're given it. So
just P1 V1 is equal to P2 V2. Split that around. The temperature is constant, isn't it?
Yep.
Yeah. So perfect. This is much quicker than me last night anyway. Okay. Question 3, railway line. This problem relates to expansion and contraction of objects with temperature. A section of steel railway has a length of 70 meters with a temperature of 0 degrees Celsius. The linear extractivity alpha of steel is 1.2 by 10 to the power minus 5 per Kelvin. But how much would the length of the railway increase if the temperature were to rise to 18 degrees Celsius? I found a converter for this. Didn't know where to go, so I looked it up, and it gave me an answer of 0.0151 meters.
Yeah, same here.
So good. I don't know if anyone. I don't know how to do it, so I
maybe just give the formula for people, if possible. Okay.
yeah, I mean, I didn't find anything because, like I say, I just thought it was going to be really straightforward. Just trying to.
I'm trying to find the formula I found last night. No,
Well, I mean, the formula that he gave us was delta T is proportional to delta L is proportional to delta T. Which, yeah, so I thought, oh, okay, so what that means is that basically you're just going to be multiplying the change in temperature, the difference, which is 18 degrees C, 18 degrees Kelvin even, just going to be multiplying that by the linear expansivity, and that gives you how much that 70 meters of track expands by. But that wasn't correct.
Yeah, it's actually, when I looked it up, like Kira, that it said that it was the change in length divided by the original length is equal to the coefficient times the change in temperature.
Right. So that's what I did. That's what I did wrong. It was the
Yeah.
That formula's not too bad. You can kind of get away with that.
Until I dug it out of the fossil record on the internet.
I didn't even look at it. I mean, I went straight for it. I was too tired. It wasn't happening.
so
Okay, is that okay with everyone? I'll try.
So then, I mean, the next question is going to be exactly the same. Just it's just from 6 degrees to 24 degrees, which is 18 degrees again, anyway.
Mm-hmm.
But I worked out that you were using 3,714 lengths of 70 meters in your 260 kilometers. So whatever your answer was going to be have to be multiplied by that. But
Did it ask us to keep it in kilometers again?
well, the first one was in meters, wasn't it? It says give your answer in meters, and then the second one says give your answers in kilometers.
Yeah.
Okay.
I didn't bother changing it in the question because the answer was about to be the same as what was given to us in the question. You know, in terms of units.
Yeah.
Yeah.
So it's the same job as the first question, right? Just different. It's still funny formula. I'll have to actually find that formula. I'll write it down somewhere. But I didn't change it to meters. I got this 6.16 meters, and I just changed that down to kilometers. I don't know if that sounds right to me. Let me know. Maybe I'm the only one that used to compare. Okay. I'll do the next question 4. So this question involves calculating the volume of oceans on Earth and finding out what would happen if the Antarctic ice cap melted. So calculate the area of the Earth covered by oceans, assume a planetary radius of 674 kilometers. Remember, only 70% of the Earth's surface is covered by oceans. I just used the surface area calculation for that. I kept it in kilometers. That's kilometers squared. So 4 pi r by 6,400. You got about 2,424.77 and multiply that by 70%. And I got 56297.34 kilometers squared. I don't know if that's too simple.
It is sort of that simple, but you've just got to remember that it's 70% of whatever your answer is, because when you're working out the area, the 4 pi r squared, that's for the whole surface area of the Earth, but the oceans, of course, are only 70% of that. So whatever you find your answer out to be.
Okay, so the original, I got that. I got the 4 pi r by 6,400 multiplied, and I got that. Whoop, right. That turned out just multiply that by 70%, and that gets the area of the Earth. Or am I going too easy?
No, it is that simple. You work it out. That's 100%. So then whatever method you use to find a percentage of that, usually what I do is I say, okay, so 100% is the answer that I've got, 1% is the answer divided by 100, and then whatever that answer is, I multiply that by whatever percentage I want. So
yeah. But you do keep the 6,400 as 6,400 in your question?
Yeah.
Okay, very good.
So squared. That's the only reason. I would usually change it back to meters, but
yeah.
Keep 8. So the Antarctic ice cap has an area of 1.4 by 10^7 kilometers squared and an average thickness of 2 kilometers. If global warming were to result from this ice melting completely, by how much would the level of the oceans rise? Assume that all ice is converted to water. If this volume of water covered the area, calculate and prove the fact what height would be required. I went dark space at this and it's not right because I don't think it's going to work by 522 kilometers. So that doesn't sound right at all. So
Again, this is another one that's a lot easier than you might at first think. It's just the formula for volume. So first of all, you work out what the volume of the Antarctic ice cap is. So it's going to be, that number he's given us there, times 2. So 1.4 times 10 to the 7 times 2 kilometres. That gives you the volume. And then your volume, area times height gives you volume. It's the height that we want. Mm-hmm. We know the volume. We know the area.
Okay. Yeah.
The volume is the Antarctic ice cap volume we've just worked out. The area is the original area that we worked out in the first part of the question.
Yeah.
And it's just one divided by the other.
So it's volume divided by area, right? The area we got in question 7.
Yeah.
I did that and I got it really wrong. Unless it did rise by 522 kilometers.
You should have a sort of a big number on the bottom and a little number on the top. What in comparison? I'm sorry, because I mean my number on the top I've got is times 10 to the 7, and the number on the bottom is times 10 to the 8.
28. Yeah. Why did I end up dividing? Okay. I see there was a question like this on the MCQ as well, and I had no idea. I don't know the area confused me. So I multiplied that out. I actually multiplied the area, the 1.4 kilometers squared, and multiplied that by 2. And I got 294 3. Oh god, 5 zeros after that. I divided that by the 56,000 And then I got 522 after that. The right form. So,
your internet connection is absolutely shite today. I have to say, you're sounding very robotic. So what was sort of the answer that you got for question 7 there? The 70% of the Earth covered by ocean.
56,297.
No.
That doesn't sound
right.
That doesn't sound right. Huh?
Sorry, Jen, what did you get?
Well, I got 3.603 times 10 to the 8.
Yeah, so did I. And my answer for question 8 was 77 metres.
Yeah, I got 78 metres, so...
Sorry, 77.7, which then you round out,
yeah.
Going wrong. Okay, we just multiplied the 64,000 by 4 pi.
Well, no, you have to square 64,000 to start off with.
Percentage wrong. Okay, I have to back and do the percentage right. That's probably what's me up here. Okay.
I worked out the area of the Earth to be 5.147 times 10 to the 8 kilometers squared. So then I worked out 70% of that, which is that 3.603 times 10 to the 8 kilometers squared.
Mm-hmm.
And then for the next part, for part 8 there, the volume of the ice cap is going to be the 1.4 times 10 to the 7 kilometers squared times the 2 kilometers. That gives you the volume in kilometers cubed, which I worked out to be it doesn't take much working out, does it? 2.8 times 10 to the 7 kilometers cubed.
Okay.
Then you rearrange your volume equation.
I didn't square the fucking kilometer. That's what I didn't do.
So then
that makes way more sense.
Yeah. So then you rearrange your volume equation. So instead of volume equals area times height, you actually end up with height equals volume divided by area. So the volume is the volume of the Antarctic ice that we've just worked out, the 2.8 times 10 to the 7. The area is the 70% area that we worked out for the oceans. You just bang that calculation in, and the answer you get is in kilometres.
Yeah.
And it asks for it in meters, so obviously you just need to change it to meters.
That makes way more sense. Thank you very much. I think is that it?
That's
I think they did well.
Can I just ask one quick question?
Go ahead.
For part 5, does anyone have a ballpark of an answer for the change in length?
In meters, I gave 0.0151. That was through the calculator online.
Yeah.
So 0.01 meters. I don't know.
That is.
Go ahead.
Yeah, that's the answer that he told me when I put my wrong answer in.
Perfect.
Brilliant. Thanks.
Could someone explain question 3 again, just for a second? I can't figure it out.
No bother. The railway one or the
it's the railway
or
one.
This one right here.
The question 2, part 3.
Question 2. Oh, the pressure at the bottom of the lake.
Yeah.
Right. The equation that you want to use here is pressure equals height times rho, which is the which he gives us in the question, times g, gravitational energy, 9.8 meters per second squared. So that's it. It's as simple as that.
Oh, okay, great. That's fine then.
Thank you. So that was the height by density by gravity. What's that equal to again?
That's the pressure.
Makes sense. Perfect.
Because he was in the lectures he was talking about a column of water that's sort of a meter squared, and as I say in the lecture he sort of equated everything out, and basically we end up with the equation that pressure equals height times density times gravity.
Makes sense. Alright, nice lads. Doesn't have to just physics if you want to ask about anything else. I think I have the chemistry on my phone, so and I attempted the maths. Say it now. If not, we're finished really early.
I did really badly in the chemistry, the lab skills. Not the calculations one, but the one where he's asking you about, is this true or false or whatever. I don't know about anyone else, but I struggled with the question and the answers, understanding what I was being asked or understanding what the answer was sort of saying.
Same. I did have to Google a few.
I didn't find it very clear at all.
Lectures, like I thought I was doing okay, and then we got to thermodynamics. I was like,
you've gone quite robotic again. You might want to stop sharing your screen just to see if it'll.
Might work.
Well,
unless you like my robot voice.
It sounds better to me.
No, I did find it hard, especially because a lot of the lab skills questions a lot of them were mainly just calculation, and you can kind of fill in the blanks, so to speak, with somebody. So these proposals really just take a wild guess and hope for the best. I did it, but it was a struggle. If anyone needs help, I'm done with it. If anyone wants to know anything, like, just text me if you don't want to say anything now. But anything else before we pop off, lads? Or
Maths? Anyone struggling with the maths?
Yeah, I'd say that's everything. Thanks so much.
no problem. Thanks so much for having us, lads. Hopefully I'll see you next week. Yeah. So, bye.
Right. I shall say goodbye then and get this uploaded.